So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 325 and in this video we continue with our exercise. We stopped here at the properties for PR values. We talked about the R values and now we go to the next line, which is this, and it says here a PR value cannot be a polymorphic. First of all, cannot be polymorphic. What means this word polymorphic? When you read something like polymorphic, polymorphismus, or something like that in C++, then think about inheritance, because when I click on this one, you will see polymorphic objects has all to do with inheritance. And you can read this one. I skip this. I go here to the examples. You can see they create a base class. They called it here base 1, and important in the base class, the function, they have one function. In this case, it's just a destructor, but can be a normal function as well, with the keyword virtual, which indicates here starts the starts a function which can be changed in a derived class. And you can see they create here another class. In this case, it's a struct. You can do this the same with a struct, and this struct is inheriting from base 1. We know this as well, and you can see here also the comments. It says now this becomes a polymorphic object, and the reason for that is we have started the base class with the keyword virtual. So when we have virtual, this inherits this one, and this function, virtual function, can be overwritten here in the inherited one. Okay, this is the word polymorphic or polymorphism and all this kind of stuff. And now we continue a little bit. It says here the dynamic type of the object it denotes is always the type of the expression. So first of all, here, what means dynamic type? And again, this has something to do with inheritance. Let's click on this one as well, and you can see here the first line. If some GL value expressions, and we know what GL is an L value or an X value, refers to a polymorphic object. The type of its most derived object is known as the dynamic type. Here in this case, careful, because GL is also an X value, and X value is also can also be an R value, because we know this cross diagram. I hope you have this in mind. And but just right now we read a PR value can't be polymorphic. So this PR value means only also this polymorphic means only for PR. So you can see dynamic types, so an X value can be polymorphic. That's here also very important, but here we are concentrating now on the word dynamic type, and like it says, is the most derived here object of the dynamic type. But here is our fast example. Let's watch this also. Here we create again a class, in this case again a struct, virtual destructor, so it becomes a polymorphic type because we have a virtual keyword here. Then we inherit this again. This is also a polymorphic type, even we have here not a virtual word here, because this virtual is inherited. That's why we use inheritance, and it is here but not written here, but it is also here. And then they are creating here first of all an object of D, and it says here already this is the most derived object. Yes, because we have here a base, and then they make a second class which inherits, and there is no more other classes which inherits from D. So this becomes the most derived object here. And then they make here a pointer, but interesting is with the class with the struct B, so it's a B pointer normally. And this one we also learned with inheritance. If you can point to a derived class, and the important part is here D here has not the same type, and this can confuse a little bit beginners, but this is because inheritance can do this. And this also occurs sometimes. You have to think about it when there is a implicit type conversion, but the first indication should be inheritance or implicit type conversion or something like that. So here, let's go to this line now. It says here the static type. Also, this is also a very nice word here, dynamic type, is now the most derived type, which is this one, and which is here the most derived, the PTR. The dynamic type of PTR is D, the most derived type, because it is a base pointer, but it points to D. So it's D, and here the static type of this PTR is B. This is the normal type, the start type, which is expecting normally. All right, these words you can, this can come along the way when you read some of these documentations, but we go on. That's enough for us. To the next property. And the next property says here, a non-class, non-array PR value cannot be const volatile. This sounds very complicated, and it's very easy. I will show you an example in a moment. Unless it is materialized. Okay, this one we will see in a moment too in an example. In order to be bound to a reference to a const qualified type. Okay, and here I make an example to explain you this kind of stuff here, because that could be a little bit confusing. The words can be confusing a little bit, right? Let's start here with non-class, non-array. I mean, when you read this one, oops, what was that? Where I jumped. Let's go back. So a non-class, it's very easy. It is just not a class which you created or other created. For example, if you create your own class, my house, that would be my class. And a non-class means it should be not a class which is created by you or by another person. But we know C++ has already built in types. For example, int, double, all this float or something like that. And when it's one of them, and it should be also a non-array, because a double int can also be an array, so it should be also not an array. Non-array means just not an array. PR value cannot be const volatile qualified. So, and here, very easy example. What does this mean? Here, this level, this number 999 is a PR value, because here we have a function and I just throw in this 999. I could throw anything else in, right? Let's throw in 43. You can see this 43 was not saved anywhere. I just throw in, it's a temporary value. It's a PR value. And what they mean here with non-class, non-array, okay, this one is a non-class because you have not created it. It's a built-in type, int, okay. That's fine. And a non-array, no, this one is also a non-array. And PR value, yes, it is a PR value. I just throw it in. And then cannot be const volatile. And we know also what const volatile means. Just the const word and the volatile word, and qualified means you can't use it with that. So when I try to write here const and then a PR value, this is a PR value which I just throw in, you can see I get here an error, right? You can't write something like that. Okay, this should be fairly easy now to understand. And let's go to the second part, which is a little bit more difficult to understand, unless it is materialized. Let's click on materialize to watch a little bit what this is. And it says here, I'm not reading this one here, but the important part, you can read this a little bit. The important part, you create here, for example, a struct again, and this one is just has just a variable in it. And then you have here, create here a variable I, which is an integer, and then you try to assign. And here, this little assignment is doing what? And if you understand this one, then you will understand a little bit materialization, because first of all, what is that here? This one, if you see something without a dot, you should know this one is S, and then it has here this close round brackets. It means you create an object, and important here is we learned normally you need a name, but this one has here no name. This is an anonymous object, and because you create it this way, it is temporarily. So at this point, this is probably the second value, the second line here. So S here, you have it, is a PR value, and we know a PR value means all time it is temporarily. Yes, I just created it here without creating an object before, so I have, and that's why it's temporary. I created just here without bound to a name. It becomes a PR value, but it says here is converted to a X value. Now we have go a little bit further. You know, this temporal value has here the value M in it, so a member M in it, and we are accessing this one here. So you create here the temporary value, you access the member, and let's read here this line, what it says here: member access expects. So when you try to do something like this, expects GL value as so since C plus 17, and I just told you what before GL value is. It's either an L value or an X value, and in this case it will convert this one to an X value, right? This is so here the whole meaning, and they mean this with materialization, because yeah, the temporal value is made when you read here on top a little bit, they made it as a result object, a temporary object created here, and this result object is then assigned to this one here. That sounds a little bit complicated, but in the end it means just they created a temporary object. Keep this for now, that's okay for materialization, because here it goes of course a little bit further. So what I just show, what I will show you in a moment is only the first one. All the other one I skip now, because then we have to watch temporary materialization a little bit more in detail, but I skip this. We go back to our part, and it says here unless it is materialized in order to be bound to a reference. So this one here I will show you again in this example. That was back to this foo here. This foo here is a function, and I created this function already, and the created function is here on top. So you can see it's a very simple function. Void return word is nothing, and then we have foo, and here I have this one is a standard thing what you see often in function calls, a const int then here reference, and it's called also ref. All right, and the important part here is we have here a const int reference, and when I go back to this one, and we talked about before the PR value here, it can't actually, let's see how I have to explain this correctly. It says here yeah, cannot be volatile. I explained you this one, and then unless, yeah, it is here this materialization part I have to say. So with other words, this part here is a PR value, right? And the point is now here to bind to a const int reference. It can't be a PR value anymore, in short. Sounds a little bit strange, but this is really the thing what it says here. Unless it materialized in order to be bound to a reference to a const volatile type. You can see, let's read this one. The reference is here, okay, this is a reference, and this reference is const volatile type. Yes, I have here a const. You can see it becomes whole a const volatile type. This is this part here, and the point here is the start point is it must be materialized. That was what we watched here. Right here is another example, but here in this case it says here just if I want bind this one behind the scene, the compiler will do this bind here. Yeah, with anyhow to this one is only possible with materialization. And we also know here normally you can't bind to references without objects normally, right? When we watch bindings with objects, right? And this special case was this const, where we could bind PR value even to a const. That was the special case. Normally you can't do this, because we already learned if you have an reference an L value reference. In this case, you need a already created object because it's referring to this one. But in this case, it is a PR value which is materialized. It is then used here to binding to this ref, and now the lifetime is extended and you can use this one here. Normally, right, I said you can't, but now you can. This is the special case. I think we talked about this in the last video a little bit. Okay, I go on a little bit to the next part. That was that. And here is again a note. Let's read this one as well. It says a function call or a cast expression may result in a PAR value of non-class const volatile qualified type, but the const volatile qualifier is generally immediately stripped out. But so this example I skip because then I need a special example to make. Let's go to the next part. And it says here a PAR value cannot have incomplete type. We have talked shortly about incomplete type, but you have to watch this side here. And an incomplete defined object type could be, for example, class type that has been declared but not defined. That was forward declaration. I don't know if we have talked about this, but you can declare. Let's see, I can, before I use, let's make it so, so for example, I have here a class test, right? And when I want to use that one in my main, I need to define the test here before I call main. When I create a class after main, which means let's go after main, let's make here my class test2 or something like this, is just for testing. Right, so now I have created here a class test2, and if I want now use this class test2 here, right, let's make here test2 to test my temp, for example this one, and try to compile this, should normally not work. Yes, should not work because there will be belt errors. So would you like to continue? Yes, let's see this one. No, oh, this one. Undeclared here, it says here test2 is undeclared identifier because it comes behind the main, and we learned already before main it should be already declared and defined. Defined means definition means so not declared but defined. This part here must be anywhere before we call this in the main, but we can avoid this. And this avoiding is in complete type with this forward declaration. And I go not into this one, but I want to show you can make something like this one. You can forward declare this, then you can use this temp in other arguments or something like that. But when do you use them real, you have still defined them, but you still can use at least the name. And yeah, they use this kind of stuff in forward declaration, but this type I skip, and this becomes the incomplete type. And I'm not going now over all incomplete types here because I think you can read this a little bit on your own. Here is an array of unknown bound. It should be very simple. Here is an array of unknown bound. Here's an array of known bound. So you can see when you not write here a number. Also considered to be incomplete till you have filled out the information. And yeah, array of elements, any array type, and so on. And then there are special other things as well with in the context here. But like I said, this is just for incomplete type. Let's go here back to our things, which is here the incomplete type. So it says here PR value cannot have incomplete type. So which means it has all time a complete type. Okay, except this void here again. Exception. I skipped this one as well because we are concentrating here a little bit more on PR value. And then let's go to the last one as well. And here we see a PR value cannot have abstract class type. What was abstract again? When you read abstract in C++, think about this equal 0 sign. And what I mean with equal 0, you have here in your struct or class anywhere a function which has this equal 0 sign. this equals 0 is an indication of that this class, this part, this struct here, or the class becomes abstract. Abstract means you can't make an instance of this struct A, for example. You have to, because it has this equal 0 signs here, and this means there is no definition. You have to define this, and you can see this one here. It's trying to make equal 0 with a definition, and that is not allowed. All right, I think you know this already. That's why I go not too much in, and that we have only to know up here ValueCategory and abstract class can be very important too. So you can't use it on, I think you can't call it anyway, because it's not, you need an instance to do, whatever. And with that said, I think that's enough for the properties a little bit. And in the next video, we will go here to the X value. The list is here very short on the X values. That's very good. And then we will finish actually this exercise and go on with the regular things. So if you have any questions, like all time, write in the comment section. See you in the next video. Bye, good luck, and like all time, have fun and never give up.